Hello, take a look at your MT11 LT2 seminar. Most of this lesson you're going to discover by yourself. So I want you to do the first 7 questions. Don't skip them because you're going to not get the learning. You're going to discover what you need to discover. So after you do the first 7 lessons, then restart this video. 7 problems, I should say. Okay, so what we're going to do, what you've learned is you've just done a bunch of translations and dilations of quadratic equations. And we're going to write equations of quadratic equations. Now, let's formalize what you've just done. If you add something, you're going to move it vertically. So if you add something to your function, add something to the x squared, you're going to translate it vertically. Now, if you do something to the x, then square it, they're going to translate it horizontally. Remember, horizontally is always backwards, so it's x minus h. So minus h means we're going to move it to the right. Plus h would be x minus a negative h. We're going to move it to the left. If you multiply your equation, your quadratic, by something, it's going to be a vertical dilation. That is, you're going to take each y value, you're going to multiply it, you're going to keep the x the same. So in other words, as a gets bigger than 1, you're going to stretch it vertically. In other words, my parabola is going to get skinnier or thinner. And if you multiply a number by less than 1, but still bigger than 0, we'll talk about that in a second, then you're going to stretch it horizontally. You're going to make it wider. So my parabola is going to be wider. It'll be a wide shape U instead of a thin U. Now, if you multiply by the x, it'll be backwards. I'm going to take each x, I'm going to multiply it by the reciprocal. That's 1 over a. So what happens is, if a is bigger than 1, I'm going to compress it horizontally. That is, I'm going to take each x value and multiply it by that, or in this case, divide it by that number. It'll get thinner. And if you stretch it horizontally by a number less than 1, that'll be a stretch horizontally, so that'll get wider. Now, let's look at what happens here. Notice, I'm multiplying by x, aren't I? So I'm going to look at the reciprocal of x. Well, the reciprocal of 1/2 is 2, isn't it? So if I multiply by 2, I'm actually going to multiply the x values by 2. So it's going to get wider. The horizontal getting wider. Now, I can check that by decimals. Let's take a look at that. So if I have, let's do our basic function, y equals, by the way, you can write f of x, g of x, that doesn't matter. Y equals x squared is my parent function. Now look what happens if I do y equals, let's go 1/2 x, get out of the denominator there, and then I'm going to square that. And notice how my blue graph is wider than my red graph, because I'm taking each of my x values, I'm multiplying, in this case I'm dividing it by 1/2, I'm multiplying it by 2. Now if I reflect something across the x-axis, if I make my function negative, that is, I'm multiplying the x squared by a negative, I'm going to stretch it, I'm going to reflect it across the x-axis. If I multiply by x by a negative, I'm going to reflect it across the y-axis. Now, if your graph is symmetric with the y-axis, you're not going to be able to tell. But if you have a translation going on, then it will switch. So what happens here I'm multiplying by negative 2/3. So I'm going to flip over the x-axis. So in other words, it's going to be going down. It'll be a sad parabola. And then it's going to make each y value multiply by 2/3. Which means I'm going to compress it. It's going to get wider. And let's check that. So I'm going to go back here. I'm going to erase my original one. I'm going to keep my parent function so I can see the difference. So I go y equals negative 2 over 3. And then I'll do x squared. See how it's getting, first of all, it's flipped. And see how it's slightly wider, because I'm taking each of my y values, I'm multiplying by 2/3. So what was 1 is now negative 2/3. So if we take a look at that, I don't know if you can see that point there. 1, now it's at negative 2/3 there. There we go. That's negative 0.5, but it's negative 2/3 about when x is 1. I wasn't quite far enough to see that. Now, notice I'm multiplying the x, aren't I? So what I'm going to do is I'm going to reflect over the y-axis. It'll be a horizontal dilation by 1/3, because I do the reciprocal of 3. Horizontal by 1/3 means it's going to get thinner. It's a stretch towards the y-axis. Now, it's symmetric across 0, 0, so you're not going to be able to tell the difference that it's actually been reflected when you graph it. So if I graph, let's check this, they're going to do negative 3 in parentheses. See the difference? When I multiply by the x, it's horizontal. And then I square that. Notice, it's been flipped over the y-axis, but I can't tell because it's symmetric. My line of symmetry is the same. But it does get thinner, doesn't it? And that's what we would say on that one. Now, to summarize this, each letter means something. We don't do too much of horizontal stretch here, but you'll do that later on. If I give you horizontal stretch, I'm not going to combine it with anything else. So the value A is going to be my dilation. That'll be a vertical dilation. So if I have something and I'm multiplying by a number other than 1, it's going to be a vertical dilation. Okay? And when A is negative, I'm going to flip it across the x-axis. K moves it up and down. K is positive, I move it up. K is negative, I move it down. And then H moves it left and right. Well, let's take a look at an application. And we talk about football fields. Although they look flat, they're not. They're crowned in the middle, so it drains towards the sideline, so you don't have a bunch of water pooling in the middle if it's constructed correctly. So what happens is we have this equation. I want to know, what does each number do to my graph compared to x squared? Okay, first off, notice we got that ridiculously small number. So in other words, it's going to make my graph, my parabola, very wide. So it's going to get wide. Wider than x of 0.00234. It's a very wide parabola. Now the negative means it's going to be a sad parabola. It's going to open down, and that should make sense because I want it to drain. So in other words, my graph is going to look, my field is going to look like that. It's moved 80 to the right because it's x minus h. So the center of my parabola will be 80 from where y equals x squared is, and it's up 1.5. And that makes sense because I want my parabola to be up a little bit higher than the sideline, so it drains. And that's we said it's between 1 and 1.5 feet, and that's how it works.